Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, um, okay, this is a video on method on how to solve a certain problem, okay, which I have posted in GC. Okay, so I just um, turn off the camera. Okay, okay, so let's look at this question two. Rachel has attempted to standardize a solution and she obtained these replicates of concentrations 0.1067, 0.1071, 0.1066, and 0.1050 m. Using a suitable test, analyze whether any one of these results can be discarded due to accidental error at 95% confidence level. Okay, before answering this type of question, we need to identify, are we going to use the t-test or q-test? Okay, so that is the first thing that we have to consider. Okay, and in order to decide that, we have to look at the keywords in the question itself. So as you can see there, okay, using a suitable test, analyze whether any of these results can be discarded. So that's the keyword, can be discarded. So out of that four numbers, 0.1067, 0.1071, 0.1066, and 0.1050. Okay, so and any of that can be removed. Is there any outlier? So it's the same meaning, but it is being stated differently, slightly different. Kan? So this is a Q test. Okay, so arrange, the first thing to do is arrange numbers according to descending order or ascending order. Okay, doesn't matter. So in this case, it's descending. So 0.1071, 0.1067, 0.1066, and 0.1050. And find the difference between the highest and the lowest value. Okay, so 0.1071 minus 0.1050, so it's 0.0021. And then difference between the uncertain value and the nearest value to it, 0.1066 minus 0.1050, which is 0.0016. So this is when we are going to test for 0.1050. Okay, so from the arrangement that we have done, you can see that there are 2 points there, one on the left hand side, which is 0.1071, and 0.1050 on the right hand side. So we are going to test for these two numbers. Is it an outlier or not? Is it can be discarded or not? And okay, so test for 0.1050 first. So Q calculated is 0.0016 over 0.0021, so it's 0.761. Q table, we can look at the table and we can get 0.829. Okay, you need to learn also on how to read the table. So in this case, since Q calculated 0.761 is lower than Q table, which is 0.829, so 0.1050 cannot be discarded. Okay, so you have to write up to this conclusion: 0.1050 cannot be discarded. Next, test for 0.1071, because this number is the other number on the far left. Difference between that number and the one next to it is 0.0004. Okay, Q calculated is 0.0004 over 0.0021. It's 0.19. Q table is the same one, 0.829. So Q calculated is lower than Q table because 0.19 is lower than 0.829. Therefore, 0.1071 cannot be discarded also at 95% confidence level. Okay, this is another question. Um, the enzymatic method for determining alcohol in wine is evaluated by comparison with a GC method. The same sample is analyzed several times by both methods. The same sample, which means the sample is only one. Kan? Okay, with the following results, percent of ethanol. The values of alcohol for both enzymatic and GC are shown in table 1. Now, using a suitable test, determine whether enzymatic method give the same value as the GC method at 95% confidence level. As you can see there, there's no various sample. Okay, it's not a multiple sample, it's just one sample. Okay, so in this case, we use this method. Okay, firstly, create column for x1. Okay, so write the numbers correctly. Okay, from the question. Okay, and get the x bar, x1 bar. So the next column, the second column is x minus x bar. So in this case, we calculate 13.1 minus 13. So we get 0.1 and do the same for the rest of the numbers. Next is square x minus x bar. Okay, and get summation of x minus x bar squared. Okay, we need this value. Okay, now the second, the GC method now. Okay, so we need to treat the GC method. GC method, write the numbers correctly. Okay, get the mean here. Okay, so from the mean, we have to work on getting the next column, which is x2 minus x bar. Okay, okay, so from here, we get x2 minus x bar squared. Okay, square everything, and sum of that is 0.2275. Okay, we need these two values, 0.44 and 0.2275, so that we can calculate the pool standard deviation. So this is the equation for pool standard deviation. Insert the value for summation of x minus x bar squared and summation of x2 minus x bar squared, and we get pool standard deviation as 0.3088. Okay. Now, we need to calculate for t. T is x2 bar minus x1 bar over full standard deviation times square root of n1 times n2 over n1 plus n2. Okay. So x2 is 13.175. x1 is 13. Full standard deviation is 0.3088 and square root of 5 times 4 over 5 plus 4. Okay, and we get 0.844. Okay. Now, T table is 2.365 because the degrees of freedom is 7 at 95% confidence level. Okay. We have, this is degrees of freedom is 7, but we have 9 sample. Okay. So because n minus 2. Okay. Therefore, since the value of T calculated is 0.844, which is lower than T table, therefore, there is no significant difference between these two methods at 95% confidence level. Let's look at this question. It was reported that in the nuclear industry, it is significant to keep the detailed records of the quantity of plutonium received, transported, or used. Okay, each shipment of plutonium pellet received is carefully checked